Hello, and welcome to this lesson on determining whether a reaction is endothermic or exothermic using temperature change. In today's lesson, we will firstly examine how temperature change indicates whether a reaction is endothermic or exothermic. Secondly, we will relate this knowledge to practical applications of endothermic and exothermic reactions. So far, you've become familiar with the basic concepts of exothermic and endothermic reactions. We know that exothermic reactions release energy, usually in the form of heat, causing the temperature of the surroundings to increase. Conversely, endothermic reactions absorb energy, resulting in a temperature decrease in the surroundings. Building on this foundation, today's lesson will enhance our chemical understanding by demonstrating how to practically determine whether a reaction is endothermic or exothermic by observing changes in temperature. As we've discussed in previous lessons, in an exothermic reaction, energy is released into the surroundings. Therefore, a typical sign that you are observing an exothermic reaction is temperature increase. If you measure the temperature of the reaction mixture and see it rising, this indicates an exothermic process. This is because the chemicals involved are releasing energy as heat. An example of an exothermic reaction is a neutralization reaction. When acids react with bases, they typically release heat. The reaction between hydrochloric acid and sodium hydroxide is a classic exothermic reaction, often making the container feel warmer. Given that exothermic reactions typically produce heat, let's have a look at some of their applications. One example is their use in heating systems. Combustion reactions in boilers and furnaces generate heat. For instance, when natural gas burns in a boiler, it releases heat that warms water. The hot water, or steam, is then circulated through pipes to heat buildings. Exothermic reactions are also used in energy generation. Power plants frequently use exothermic reactions. In coal-fired power plants, coal combustion releases excellent heat, converting water into steam. This steam drives turbines to generate electricity. Let's move on to endothermic reactions. Endothermic reactions absorb energy from the surroundings. Accordingly, a telltale sign of an endothermic reaction is temperature decrease. If, upon measuring the temperature of the reaction mixture, you notice a drop, this signifies an endothermic reaction. The chemicals are pulling in energy from the surroundings, thus cooling the immediate environment. One example of an endothermic reaction is salts dissolving in water. Many salts absorb heat as they dissolve, causing the temperature of the solution to drop slightly. Given that endothermic reactions typically absorb heat from their surroundings, they have various applications. As we've mentioned in a previous lesson, endothermic reactions are the principle behind cold packs. When you snap the pack, you begin an endothermic reaction, absorbing heat from your skin and thereby causing a cooling effect. These are commonly used to reduce swelling and pain from sports injuries. Some reactions can be either exothermic or endothermic, depending on the specific chemicals involved. One example of this is precipitation reactions. When solutions react to form an insoluble product known as a precipitate, the temperature change can vary. Measuring the temperature change will help determine the heat transfer involved. To determine whether a reaction is exothermic or endothermic using temperature change, you can follow this simple process. Step 1 is to measure the initial temperature of the reactants before mixing. For step 2, you must proceed with the reaction. Step 3 is to measure the final temperature of the mixture after the reaction has occurred. Finally, step 4 is to compare the initial and final temperatures. If the final temperature is higher than the initial temperature, the reaction is exothermic. However, if the final temperature is lower, the reaction is endothermic. Let's dive into some GCSE level questions to apply our understanding. Here is our first question on neutralization reactions. When hydrochloric acid, HCl, is mixed with sodium hydroxide, NaOH, the temperature of the mixture is observed to increase from 25 degrees Celsius to 35 degrees Celsius. Is this reaction endothermic or exothermic? Pause the video here to have a go yourself. To answer this question, you must begin by noting the initial temperature of the reactants. This is 25 degrees Celsius. After the reaction occurs, measure the final temperature. This is 35 degrees Celsius. Then, you must compare the initial and final temperatures. Since the final temperature, which is 35 degrees Celsius, is higher than the initial temperature, 25 degrees Celsius, the reaction releases energy. In conclusion, this temperature increase indicates that the reaction is exothermic. Here is our second question on dissolving ammonium nitrate in water. When ammonium nitrate, NH4NO3, is dissolved in water, the temperature of the solution changes from 22 degrees Celsius to 15 degrees Celsius. Is this process endothermic or exothermic? Pause the video here to have a go yourself. To answer this question, you must begin by noting the initial temperature of the water. This is 22 degrees Celsius. After dissolving ammonium nitrate, measure the final temperature. This is 15 degrees Celsius. Then, you must compare the initial and final temperatures. Since the final temperature, which is 15 degrees Celsius, is lower than the initial temperature, 22 degrees Celsius, the reaction absorbs energy. In conclusion, this temperature decrease signifies that the reaction is endothermic. In today's lesson, we delved into determining whether a chemical reaction is endothermic or exothermic by observing changes in temperature. We began by recalling that exothermic reactions release energy, usually causing a temperature increase in the surroundings, while endothermic reactions absorb energy, leading to a temperature decrease. We also considered some of the applications of these reaction properties, ranging from heating systems to cold packs. By observing temperature changes during these reactions, we can easily classify them and gain a deeper understanding of the energy dynamics involved in chemical processes.